So as you guys can probably imagine, the problems that we're doing with these solving equations where we're solving for a variable can get slightly tougher in terms of how they look and how they're set up. This problem, and the sort of problem we're going to do in this video, is a little bit different because we have multiple y's in our problem now. We have a y on this side, and we have a y on this side. So, if we want to get y by itself, we can't have multiple y's running around in our problem. That's kind of an issue for us, because you can't get y by itself if there's more than one of them. So we need to lump our y's together somehow and get them all in one nice package. So, there are two ways we can do this. You can either put all the y's over here, or you can put all the y's over here. It really doesn't matter which way you go about it. If you wanted to, just like if this was a minus 5 sitting right there, you would do a plus 5 on both sides. It's a minus 5y. You are completely allowed to do a plus 5y on both sides of the equation. Now notice when I do this, I would cross those out, and I put this underneath the other y because I'm going to combine these. 3y plus 5y is going to be an 8y. That would work out perfectly. The other option I have, if I wanted to move, so that moved the 5 over here. If I wanted to move the 3 over here, it's a positive 3y. I would have to subtract 3y on both sides. Then you do negative 5 minus 3, and you'll end up with negative 8. Negative 8y. Either way is totally fine. Typically when I do these problems, I feel there is less room for error. I always try to make my variable positive. So if I have a minus 5y right here, negative 5y, I'm going to get rid of that by adding 5y on both sides. So I feel on this problem it was easier to move it over here, although you could do it either way. When I do that, I get 2 left over here, that's it, equals 8y minus 30. And now it should look a lot like we did in the last video. We're going to add 30 to both sides. We get 32 equals 8y. My answer when I divide both sides by 8 is going to be y equals 4. Or 4 equals y, exact same thing. And if you wanted to, you could plug that answer in, of course, back into the original problem on both sides and see that the two sides are equal. It will end up working, and I'm not going to show that in this video. But you could. Second problem here, I have p's on both sides of my equation, and to make matters worse, I have a 2 outside these parentheses. I'm going to get rid of my parentheses by distributing. So this side's going to stay the same. I'm going to get 2p minus 14 on this side. And once I get to there, I need to do it just like the last problem. Well, if I do a minus 4p on both sides, I'm going to end up with a negative p, which is not wrong in any way. It's totally fine. But I would rather keep my p positive, so I'm going to move my 2p over. I'm kind of looking ahead and seeing that'll leave me with a positive variable, positive coefficient on my p. So when I do that, these will cancel. 4p minus 2p is 2p plus 10, didn't do anything with that yet, equals, and on this side, just negative 14. Now, just like any other problem, you just keep on going. Subtract 10 from both sides, you get 2p equals negative 24. And finally, you divide both sides by 2, you get p equals negative 12. So, the next problem I'm going to show up here is the reason why I make you guys draw that line in your problem. This problem is one that I guarantee, now that you've seen this with these two problems here, kids will make this mistake, and it's very, very common. I think the line goes a long way towards avoiding it. So, if you're feeling ambitious, go ahead and pause the video now and see what you can do with this number 3 over here. Try it out, pause the video, and see if you get it right. I'm going to walk you through this though. And the first thing I'm going to do on this video right now is show you the way that I bet a lot of people do this wrong. People get in the habit, oh, I got to get my x's together. I'll do a minus 2x, so I get 7. Don't write this down, by the way. 7 plus x equals 40, like that. And then they're like, oh, I'm going to solve it. If you do that, you get x equals 33. Again, don't write this part down. When I draw my line here, the issue with this was I did a minus 2x and I did a minus 2x on the same side of my equation. You're not allowed to do that. I didn't balance myself out by doing it to both sides. I took away 2x twice from the left side. These are not equal anymore. You can't do a minus 2x like this when it's on the same side of the line. It would have to be over here, and that doesn't help us. So this 33, I'll write that over here just for reference in a little bit, is the wrong answer. You're not allowed to do that. What I'll end up doing instead on this one is actually thinking back to combining those like terms from earlier in the year. If they're on the same side of the line, we're going to do our circles and squares like we learned. Lump these together. 2x plus 3x is 5x. So I get 5x, nothing to do with the 7 there, plus 7 equals 40. And now we just solve that. And when you go through and solve this problem here, you end up with 33 over 5, which as a decimal I believe would be 6.6 if you wanted to, but this is a totally fine answer as is. So when we solved it the old way, we got 33 as our answer, but the answer was 6.6, not even close to the same thing. You have to be careful about that, and I actually want you guys to write this down as a note because it's that important. So, same side of line, or same side of equation, if you want to write it that way, means you combine like terms. Can't tell you how many times I see kids making that first mistake I showed where you do the minus 2x on both sides. You have to watch out. If it's on the same side, you clean things up. You do not do subtracting or adding to both sides. Then we have one more problem on this video, and I'm going to go ahead and walk you guys through it. Again, if you're feeling ambitious, try it out for yourself first. So, parentheses, there's a lot going on here. This problem's kind of a mess. First thing I'm going to do is distribute and combine like terms. Try to clean it up a little bit. I get negative 20x minus 30, and then the minus 5x just stays there, equals 10x. I'm going to clean up things on the same side of the line. Negative 20x minus 5x makes a negative 25x. Minus 30 is still there, 10x is still here. I want to get all my x's together, and the easiest way to do that, since this side just has an x already, I'm going to go ahead and bring over my negative 25x. So I get negative 30 equals 35x, and to solve that, I'm going to divide both sides by 35, because I want to get x by itself. So when I do that, negative 30 over 35, if I choose to reduce it, which I should, divide both by 5, I get negative 6 over 7 for x.